In this video, we'll be talking about linear inequality. So let's get started. So when you say an expression is a linear inequality, the first thing you want to look at is the word linear. So linear implies that you are talking about expressions whose order is 1. In other words, those expressions have variables that have a power of 1. Then what about the inequality part? The inequality suggests that the two expressions you're trying to compare, they are not necessarily equal. So when you have two expressions that they are trying to compare and they are not equal, you call you call that inequality. But then if you are dealing with linear expressions, then that becomes linear inequality. Later on, we're going to talk about quadratic inequality. But in this video, we'll be talking about linear inequality. So let's take a look at an example. If you have an expression like this, 2x plus 1 greater than 5x minus 1. This is an example of a linear inequality. So why do we call it linear? It's linear because this unknown variable, which is x, has a power of 1. And the same thing applies here. All the unknown variables have a power of 1. Then why do we call it inequality? The reason is what the symbol, the symbol we use to compare both sides happens to be a non-equal sign. So when you have anything like this, which is greater than, this is greater than, this is greater than or equal to. If you see something like this with this sign, we call that greater than or equal to. So what you imply is that what you have on the left is greater than or maybe equal to what you have on the right. Then if you see the sign, this is less than sign, less than. Then if you see this with this equality sign, it is less than or equal to. So then if you see this, it means not equal to. So this not equal to means it could be less than or it could be greater than, but you are sure or certain that it is not equal to. So this is called not equal to. But in our discussion, we'll be dealing majorly with these four symbols in our discussion today. So the question now is how do you solve a linear inequality? So if you are asked to look for the value of x in this case, how do you go about it? So to solve a linear inequality, you need to understand certain basic rules. The rule is very similar to a linear equation, very, very similar, except in few scenarios. You know, in linear equation, we can transfer whatever you had on the left, you add on the right. So what that means is if I have, let's say, A to be equal to B, if I add C to the left, I can equally add C to the right, and that makes the two sides to be equal. Now the same thing goes to inequality. If I have A greater than B, I can add C. If I add C to whatever I have on the left, I should add C to whatever I have on the right, and this greater than sign stands true. And even if it's less than, so the same thing. So an example is this: if I say 2 is greater than 1, right? If I add 3 to this side, that will give me 5. If I add that same 3 to this side, that will give me 4, which means this statement still happens to be true. So in this particular case, the inequality rule is similar to that of equation. Then the same thing goes to subtraction. If you subtract, you can subtract from both sides. If I say A minus C, it will still be greater than B minus C as long as this one stands true. Now, where we have a difference is this. When it comes to multiplication and division, then that's where inequality differs from equation. So let's take a look at this example. So if I multiply A by positive number, so let's say I say A times a positive number. So let's say A times C. It will be this sign will be maintained if C is positive. But if C is negative, if you multiply both sides by a negative number, the rule states that you are going to change the sign from greater than to less than, and if it is less than, you change it to greater than. So this is what happens if C is negative. So let me give you an example. So let's say I have something like this. I have something like minus x greater than 5. If I want to find the value of x, I can multiply both sides by minus 1. If I do that, I'm going to change the sign from greater than to less than. Then I'm going to multiply this by minus 1. Therefore, x will be less than minus 5. So that is one important rule you have to take note of. If you multiply both sides by a negative number, you flip the sign. The same thing goes to division. If you divide both sides by a negative number, you also flip the sign. So let me show you why this makes sense, why you need to flip both sides. So let's take a look at this scenario. So if I have minus x to be greater than 5, right? If I transfer to both sides, transfer to both sides could mean if I add x to both sides. So which means if I take x and add to both sides, this becomes 0 greater than 5 plus x. Then if I subtract 5 from both sides, which is minus 5, that is 0 minus 5, greater than 5 plus x minus 5, I'm going to get minus 5 greater than x. This cancels out this. So basically what I've just done is I've transferred this to this side, which becomes minus 5. I've transferred this to this side, which becomes plus x, right? Now if you check this, you will see that we now have minus 5 is greater than x. And if you say minus 5 is greater than x, the implication is that x is less than minus 5. Because if I'm greater than something, then that thing is less than myself. So by taking away the minus from the x, you've indirectly flipped. You've transferred to both sides. But if you flip the whole thing around, it becomes x less than minus 5. In other words, if you try to rotate, just imagine that you have minus 5 greater than x, and you try to rotate this by 180 degree. That is, you try to rotate this rectangle. So imagine you have this rectangle, you rotate it by 180 degree. What happens is you get x less than minus 5. So this just shows why you always flip this sign whenever you multiply by a negative number. So that's a very important rule you have to take note when dealing with linear inequality. So let's take a look at an example. So say you have 2x plus 3 less than 5x plus 7, and you want to look for the value of x, right? So how do you go about this? What you want to do is to collect like terms, just as usual. You take 2x, you transfer 5x to this side, that becomes minus 5x. You take your 3 plus 3 to the right, that gives you 7 minus 3, because once you cross the other side, it becomes minus. Then what do? You solve for both sides. 2x minus 5x, that's minus 3x, less than 7 minus 3, that gives you 4. So what's the next phase? The next phase is to divide both sides by minus 3. And because you are dividing both sides by a negative number, you must flip the sign from less than to greater than. Then you divide both sides by minus 3. And now you cancel this, and x is greater than minus 4 over 3. So this is the answer to this question. We're going to solve more questions from past question later on. But before we do that, let's take a look at another concept, which is how do we represent linear inequality on a number line? So what's a number line? It's just a line that shows the location of a number on a real number line, and it shows, in the case of linear inequality, it tells you the direction. So let's take a look. So let's say I ask us to represent x greater than 2 on a number line. So what does it mean? Or how do you do that? So what that means is you're going to indicate on a number line where you have 2. So this is 2, right? You know, number line is something like a kind of straight line with spaced numbers. So this could be 1, this could be 0, this could be -1, and so on. This could be 3, and this could be 4. So a number line shows you where x is on a straight line, on this number line. So what you're going to do is you're going to indicate that x is right on top of 2, but not just on top of 2, is greater than 2. So greater than 2 implies is on this zone, right? So number line shows you all the possible values of x, and in this case, if x is greater than 2, it means x could be 2.1, 2.2, 2.3, 2. Whatever, then 3, 4, 5, and so on till positive infinity. So that's this region shows the region within which you could find x, because inequality means the x is not a single value. It could be any of the value that is from a particular point. So when I say x is greater than 2, what I'm saying is x is anything that is above 2. So 2.11 is above 2. That's a potential value or a possible value of x. 100 is also greater than 2. Is also a possible value of x. So when you say when you are asked to represent inequality on a number line, you are asked to indicate the region within which x could be found. So this is how you represent this on a number line. What about if you have this? You have equality, right? You know, this, the first one has no equality sign, but this has equality sign. So very straightforward too. You just indicate where the 2 is on the number line, then you put your marker on top of it, then you indicate that it goes towards direction which is greater than. But there's one more thing you will do. You need to shade this marker. You need to shade inside. So if you see the first one, I didn't shade inside. If you shade inside, you are saying that it is also equal to 2. So this means x is greater than or equal to 2. So by shading it, you are saying that x could potentially be 2 or something above 2. So this is how you represent this particular example on number line. So what about something like x less than -1? So how do you represent this on a number line? The same thing. You indicate where the -1 is on the number line, right? This could be 0, this could be 1, and so on. Then you indicate, you place a marker on it. You don't shade if there's no equality sign here. Then you indicate that it is less than. Less than means you go to the left. So this is the range of the possible values of x is less than -1. So let's take a look at another example. So if you have something like this, you have something like 2 less than x less than 10. So what does this mean? Now you can break it out this way. You can say, you can take it out this way. 2 less than x and x less than 10. That's basically what this expression means. So there are two parts, like two inequality in one, right? So how do you represent this part on a number line? Well, you need to make the x to be on the left. And to make the x to be on the left, just flip this rectangle about 180 degrees. And if you do that, you're going to get x greater than 2, because if 2 is less than x, then it implies that x is greater than 2, right? Now, so these are the two things you are going to plot on a number line. So let's see how to plot this on a number line. So you have 2 here, right? And you have, let's say our 10 is here, right? So what we want to do is to indicate where is x greater than 2. X greater than 2, you put your marker here, then you indicate greater means to the right. And for the second part, x is less than 10. Then you have this. Less than means you go to the left like this. So now both of them join. So it's like this and like this, right? So what this means is this particular expression lies within this zone. So the value of x is between 2 and 10. So that is what this expression implies. That is something greater than 2, but not up to 10. So it's within this region. So we've talked, that's how you represent this kind of expression on a number line. So let's take a look at some examples from past questions. So let's solve some questions. So this time around, we are going to take some questions from TestDriller UTME app, and I'm going to use the question search feature to extract questions related to inequality. So the first question I'm going to solve is question 19 from the year 2015. So here's the question. The question states that we should solve for this inequality. That's 1 divided by 3x plus 1 over 4 greater than 1 over 2x plus 1 over 3. So this is the question, and the goal is to look for the value of x. So let's solve this. So what do I do first? So what I want to do is to deal with the fractions. So how do you do that? So you just look for the LCM, or the lowest common multiple. And this time around, I'm going to factor in the x. So you have 3x, you have 4, you have 2x, you have 3. So one way you can easily get a common factor is if you see that, first let's deal with the numbers. If you have x and numbers, you want to get the LCM of the numbers first. So to get the LCM of the number, just focus on 3, 4, 5, and 3. So since we have 3 and 3, so we know 3 will be part of the factor. Then 2 and 4. Since 2 is in 4, then 4 is part of the factor that we're interested in. So just multiply this 3 times 4, that will give you 12. So 12 is the lowest common multiple as regards the number. So the next is to deal with the x. Since you have x as part of the denominator, you have to also include the value of x. So now what this implies is you're going to multiply all the expression, each of these expressions, by 12x. So what that implies is you multiply, since we decided to multiply, you just multiply it as follows: 12x times 1 over 3x, then plus 12x times 1 over 4 greater than 12x times 1 over 2x, then plus 12x times 1 over 3. So the next thing we want to do is to simplify. So x cancels out x, 3 in 12, that gives 4. Then 4 in 12x, that gives 3x. Then greater than 2x in 12x, x cancels out x, 2 in 12, that's 6. Then plus 12x times 1 over 3, that gives 4x. So what's the next step? The next step is to solve for x. You collect like terms. So you have 3x on this side. Take the 4x to this side, that's minus 4x. Then greater than 6, which is this. Then the 4 goes here, that's minus 4. But eventually you have 3x minus 4x, that's minus x, greater than 2, that's 6 minus 4. So what's the next phase? The next phase is to remove the negative sign on the x, and that simply means you multiply both sides by minus 1, or you divide both sides by minus 1. So if you multiply both sides by minus 1, you're going to reverse, you're going to change the sign of this from greater than to less than, and that gives 2 times minus 1. Therefore, x is less than minus 2. So this is the answer to this question. We're going to be solving some questions from UTME past question, and I'm going to use the question search feature in the TestDriller UTME app to extract some question as regarding equality. So let's solve some questions. So we're going to take question number 19 from 2015, and let's see how it goes. So this question goes as follows. You have x over 3 plus 1 over 4 greater than x over 2 plus 1 over 3. And the question is that we solve for this inequality. So let's take a look at how to go about it. So in this case, the first one we do is look for the LCM. So what's the lowest common multiple? Since we have 3, so 3 will be the LCM, then will be part of the LCM, right? Then we have 4 and 2. So since 2 can go in 4, so just focus on the 4. Multiply by 3 and that gives you 12. Now, what this implies is you're going to multiply each of these terms by 12. Then that means you're going to say 12 times x over 3 plus 12 times 1 over 4 greater than 12 times x over 2 plus 12 times 1 over 3. So this will give you 4x, that's 3 in 12, that's 4x, plus 12 times 1 over 4, that gives you 3, greater than 6x, then plus 4. So the next thing you want to do is to solve for x. So you collect like terms. So you take this 6x to the left, that gives 4x minus 6x greater than 4, which is on this side, minus 3. If you take this to the other side, the sign changes from positive to negative. So 4x minus 6x will give you minus 2x greater than 1. The next is divide both sides by minus 2. That is a negative number. And as you can recall, whenever you divide by a negative number or multiply by a negative number, this inequality sign changes to the opposite. Then you have 1 over minus 2. The next therefore is now less than minus 1 over 2. And this makes option D the right option. So let's take a look at another question. So this time around, I'm going to look at question number 14, 2008. Question number 18, 2014. So the question goes as follows. You have x divided by 2 plus 3 over 4 less than or equal to 5x over 6 minus 7 over 12. So what you want to do here is to, as we did earlier, to look for the lowest common multiple. That is, which number can 2, 4, 6, and 12 go in? And that number should be the minimum that these 4 numbers can go in. It turns out that 12 is that number because 2 can go in 12, 4 can go in 12, 6 can go in 12, and 12 can also go in 12. So what that means is you multiply all through by 12. So if you do that, you're going to get 12x over 2, then plus 12 times 3 over 4. Then here you have 12 times 5x over 6, then minus 12 times 7 over 12. So what happens here is this. You end up simplifying. So this will give you 6x, which is 2 in 12. Then plus 4 in 12, that's 3 times 3, that gives you 9, less than or equal to 6 in 12, that's 2 times 5x, that gives 10x, then minus 7. Then you want to collect like terms and simplify. So this means you take all the x to the left, 6x minus 10x less than or equal to, you take 9 to the other side. That gives you minus 7 minus 9. Then this gives you minus 4x less than or equal to minus 16. So what we want to do next is to divide both sides by minus 4. And if you divide by a negative number, the sign changes to the opposite. Then this is minus 16 over minus 4. Minus times minus 4 cancels 4. So you are left with x greater than or equal to 4. So this is the right answer, and that makes option greater than or equal to, so that makes option C the right option. So that's it. So this brings us to the end of this video.